looking at is position. Can everybody see? Is the DocuCam reflecting on the screens there? Great. So position requires two things. It requires how far am I from a point of reference. In this case, it's Carlos. Carlos, famous. And a direction. Right, so Carlos had to specify how far I am away from him, and in what direction. So 5 meters in front of him, 2 meters to his right. Now, let's think about this. So, what did Carlos need to answer this question? First of all, he needed some sort of point of reference. So, what do we need to specify position? So, first of all, an agreed upon point of reference. Excuse me if I'm not spelling absolutely correctly. So this is a fixed point that we take as we are going to measure locations from this point. Then we also needed, and this is a slightly more subtle thing, we also needed a set of reference directions. So we can say we need an agreed upon set of reference directions. Now, for Carlos, the reference directions are quite simple, and all of us use them every day. It is left, right, in front of, behind, up, down. You can pretty much describe the location of anything that you see in terms of that. That monitor is about 7 meters in front of me and about 4 meters to my right, and slightly above me as well. So using these reference directions that we all know, in front, behind, left, right, up, down, plus a point of reference, we can define things or their positions around us in space. But does that make pretty logical sense? It's not if I'm kind of missing you. It's a bit pedantic to go into this because we all do this every day. If you walk to the shop, you see the shop is so far ahead of you, therefore I must walk in that direction. So we all have a sense of direction, we all have a sense of distance. Right? And these things, all of this, defines a frame of reference. Now we can formalize this a bit. We can draw ourselves a little picture just to get things going. Carlos, I'm not going to draw, this is not an accurate depiction of you. I'm not an art student. But for the sake of argument, let's say this is Carlos. Not to scale. And what we know is we've got a point of reference. So in this case, it would be Carlos's position. So that's our point of reference. And then we've got some reference directions. Now in one dimension, let's say we've got to the left, and we've got to the right. So this is a reference direction. Now, we can formalize this by, let's call this, my drawing is a bit squiggly, but let's call this, it should be a straight line, we're just going to call this the x-axis. Right, so I'm going to give it a little value x. So, for example, let's say that is 1 meter to the left of Carlos. I'm going to denote that point by saying x is equals to 1 meter. If I've got 2 meters to the right of Carlos, I'm going to say that is x equals minus, sorry, there's a minus there, 2 meters. So instead of saying to the left, to the right, I define a single axis. We will call it the x-axis. Anything that is to the left of our point of reference, we will say is along the positive x-axis. Anything that is to the right will be along the negative x-axis. So positive numbers indicates things to our left. Negative numbers denote things to our right. And just for interest's sakes, later on, obviously these aren't the only 2 reference directions Carlos has. He's also got on top of and below, and in front of and behind. So for example, in a fully 3-dimensional world, we would have been able to set up a second axis, which we would have called the y-axis. And this would allow us then, at least in 2 dimensions, to specify positions. And then, unfortunately, I cannot draw 3D, but if we were to put in front of and behind in as well, we'd get an axis sticking out of the board and one going into the board. And that's really the space you're living in. So in 3-dimensional space, we can use these 3 reference directions in front, to the side, or on top of it or below, to specify positions. So this brings us now to the formal definition of position. So how do we define position? So we're first going to look at 1 dimension. So in 1 dimension, your position is your location with respect to a fixed point of reference. And remember, location implies how far from the fixed point and in what direction. So we need 2 things to specify a position, 2 bits of information. How far and in what direction. Right, now, to see why we bother with position, you'll see this actually contains